Hello 10th standard, it's time to do exercise 15.2 from probability. There are in all 5 questions out of which you have already done questions of type 3, 4 and 5. You did such questions last year. Let's take a look at question number 1. So question number 1 we have two customers, Sham and Ekta, are visiting a particular shop in the same week, Tuesday to Saturday. So these are the days when the two customers visit the particular shop. Each is equally likely to visit the shop on any day as on another day. So the customers, Sham and Ekta, could visit the shop on any day. From Tuesday to Saturday, they could visit the shop on any given day. The chances are equal. What is the probability that both will visit the shop on same day? Then what is the probability they will visit the shop on consecutive days? And the third is, what is the probability that they will visit the shop on different days? Now for writing the answers for these, writing down the probability for the events asked, let us write down the sample space. What are the possible outcomes? So the outcomes will depend on when Sham and Ekta visit the shop from Tuesday to Saturday. Now, to write down the sample space for this question, it will be exactly like the combination of numbers on two dice. So let's make a table before we write down the sample space. So on this side, I'm going to write down when Sham visits. And on this side, I will write down when Ekta visits the shop. So they can visit the shop from Tuesday to Saturday. So Sham can visit on Tuesday, Wednesday, Thursday, Friday or Saturday. He can visit the shop on any of these 5 days. And Ekta can also visit the shop on any of these 5 days from Tuesday to Saturday. So these are the possibilities for Ekta. 5 possibilities for Ekta, 5 possibilities for Sham. But together how many possibilities they have? So let us assume that Sham visited the shop on Tuesday, then Ekta could visit the shop on any of these 5 days. So Sham visits on Tuesday and Ekta also visits on Tuesday. This is the first possibility. Second possibility, Sham visits on Tuesday but Ekta visits on Wednesday. Then Sham visits on Tuesday but Ekta visits on Thursday. Sham visits on Tuesday but Ekta went to the shop on Friday. And then Sham went to the shop on Tuesday but Ekta went on Saturday. So this is how you will be listing all the outcomes. Each of these outcomes for one person will have a combination with 5 outcomes for the second person. So Tuesday combined with 5 options for Ekta. Then again for Sham, the second option is Wednesday. His second option will be combined with 5 options for Ekta. So we get the sample space in this way. So we have a combination of Wednesday with Tuesday, Wednesday with Wednesday, Wednesday with Thursday, Wednesday with Friday, Wednesday with Saturday. So complete the table this way and you will get your sample space. So I have completed the table and I have obtained my sample space. So how many possible outcomes are there? So 5 outcomes for Sham and 5 outcomes for Ekta combined together give me a total of 25 outcomes. Now let us answer what they're asking. In the first part, they are asking what is the probability that they visit the shop on same day. So probability both visit the shop on same day. So let's obtain our answer from the table on same day. So both visit on Tuesday, both visit on Wednesday, both visit on Thursday, Friday, Saturday, Saturday. 1, 2, 3, 4, 5. So I've got 5 out of 25 outcomes. Then the second one is probability they visit the shop on 2 consecutive days. They visit on consecutive days. Now you should know the meaning of the word consecutive. Consecutive means one after the other. The days which come one after the other. Like Tuesday and Wednesday. One visits on Tuesday, the other visits on Wednesday. Or the opposite. So let's count those consecutive days. I'm marking with black now. So this is a one possibility. Tuesday, Wednesday. So Sham visits on Tuesday and Ekta visits the next day. Or it could be the opposite, where Sham visits on Wednesday but Ekta visits on Tuesday. So 1, 2. Keep looking for such outcomes in the table. So consecutive days, Tuesday, Wednesday, we have these two possible outcomes. Now the next two possibilities could be Wednesday and Thursday. So Wednesday and Thursday. So Wednesday, Thursday, or Thursday, Wednesday. You have to take both orders. Then Thursday and Friday. So Thursday and Friday. This is Thursday, Friday, and this is Friday, Thursday. One visits on Thursday, the other one visits on Friday. Or it could be the opposite. The second person comes on Friday and the first person goes on Thursday. Then we have Friday and Saturday. So we have Friday, Saturday, or Saturday, Friday. First person goes on Friday, second visits on Saturday, or first person visits on Saturday, second visits on Friday. So how many such outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 outcomes are there. 8 out of 25. So there are 8 outcomes which tell us that the customers visited the shop on consecutive days. Final case is when you have to find out that the customers visited on different days. So probability they visited on different days. This could be calculated from here. Out of 25 possible outcomes, 5 outcomes told us that the shop was visited by them on the same day, and for the remaining other outcomes the customers visited on different days. So out of 25 subtract 5. This is one way of doing it, or you can just count from the table, delete the ones which show when they visited the shop on same day. So we want different days. This will be deleted, this will be deleted, this will be deleted, this will be deleted, and this will be deleted. Count all the other ones. The crossed ones will not be counted. So out of 25 I have crossed 5 outcomes. So I've got 20 by 25, and you can give the answer in simplified form. Let's take a look at the next question. Question number 2. A die is numbered in such a way that its faces show the numbers 1, 2, 2, 3, 3, 6. This is not a regular die. This is by a biased die. We don't have 1, 2, 3, 4, 5, 6. This manipulation with the die. It is thrown 2 times. So one dice thrown twice. You know how to write down the sample space. The total score in 2 throws is noted, and the sum obtained is noted down. Complete the following table, which gives a few values of the total score on 2 throws. So they have made a table the way I did for writing down the sample space. These are the numbers which you could have on one die, and these are the numbers which you could have on the second die. Combination will give us these totals. So if 1 is combined with 1, total will be 2. 1 combined with 2, total will be 3. 1 combined with 2, total will be 3. So there are these possible values showing the sum obtained on both the dice. Based on this, what is the probability that the score is even? So how many even values did you get in this listed outcomes? In these listed outcomes, this actually gives you this is not the sample space, although the sample space would be writing down in this way, in the form of ordered pairs. This is how you write down the sample space. This is not the sample space. This is only showing the sum obtained. So if you had to write down the sample space, you would be writing down ordered pairs. So these are the combinations. So 1 combined with all of these. So you will have 1, 1. If I had to just list the outcomes, in question number 2, where the die has numbers 1, 2, 2, 3, 3, 6, now I will be doing without the table. Without making the table, I'll directly write down what the sample space would be. So the sample space will have every number combined with the 6 outcomes. So 1 combined with these 6, then 2 combined with these 6, this 2 combined with the 6, 3 with all 6, 3 with all of these, and this last value with all of these. So that's how you can write down the sample space directly. So we'll have 1 with 1, 1 with 2, 1 with 2, 1, 3, 1, 3, and 1, 6. So 1 has been combined with all of these. Same way you can write down for the remaining outcomes. So I have listed all the possible outcomes when the die is numbered or marked with these values. So these are the 36 possible outcomes. Based on these outcomes, you have to fill out that table. So the sum obtained from these two will be 2. Let's quickly go through the total. 3, 3, 4, 4, 7. 3, 4, 4, 5, 5, 8. Now, keeping this in mind, if you look at the question, you would know how they have filled up the table. So let's quickly take a look at this, and side by side let's take a look at the sample space as well, so that it's easier to do. So let's look at the sample space and fill up the table. From the first row, obtained the total in the first row. 2, 3, 3, you can see 4, 4, 7. And then for the second row, 3, 4, 4, 3, 4, 4, 5, 5, 8. This way you have to complete the table. So in the next row, what would you have? You would have 3, they have filled it, 4, 4, 5, 5, 8, 4, 4, 5, 5, 8. So 3, 4, 4, 5, 5, 8. Then for the first, second, third, fourth row. Fourth row is this one, 4, 5, 5, 4, 5, 5, 6, 6, 9, 6, 6, 9. Now let's look at the next row. 4, 5, 5 again. 5 is already there. 6, 6, 9. 6, 6, 9 is already there. They have filled up the last row as well. If you want, you can check. 7, 8, 8. 7, 8, 8. 9, 9, 12. 9, 9, 12. Now looking at these sum obtained, you have to answer what is the probability that the total score is even. So out of these values, how many even values do you have? So let's count. We have 1, I'm just encircling, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the probability will be 18 out of 36. What is the probability that the total score is 6? So count how many times did you see 6 here. So I see 6 here. 1, 2, 3, 4. 4 times. 4 out of 36. Then at least 6. At least 6 means 6 or more. The sum should be 6 or more. So you could do it two way. Either count the sum which have 6 or more answer, or delete the ones which have a value less than 6. So I'm deleting the ones which have a value less than 6. So this gets deleted, this gets deleted, this. All the values with answer less than 6 will be deleted. So almost all the values are being deleted. So I'm left with these values. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So 15 out of 36. Now let's do question number 3. Question number 3. A bag contains 5 red balls and some blue balls. The probability of drawing a blue ball is double that of a red ball. Determine the number of blue balls in the bag. Maybe you remember doing such a question last year. To begin with, what we will do is we will assume the number of blue balls as x, and then we will make an equation from here. Probability of blue ball equals to 2 times the probability of red ball. Question number 3. Let number of blue balls is x given number of red balls is 5. Therefore, total number of balls is 5 plus x. According to question, the probability of blue ball is equal to double, means 2 times the probability of red ball. Let's write down for blue ball. Number of blue balls is x over total 5 plus x. This is a binomial. Then 2 multiplied with probability for red ball. So number of red balls is 5. The total will be in the denominator. So this becomes x over 5 plus x equals to 10 over 5 plus x. We have the same denominator on both sides. This will get cancelled. X comes out to be 10. So the number of blue balls is 10. Let's do fourth question. A box contains 12 balls, out of which x are black. Now this time they have used a variable themselves. If one ball is drawn at random from the box, what is the probability that it will be a black ball? So there are 12 balls, out of which x are black. The probability of black ball, number of black balls over total number of balls, x by 12. Further, if 6 more balls are put in the box, so 6 black balls are put in the box, this will increase the number of total balls, as well as this will increase the number of black balls. So total balls will be 12 plus 6, 18 in the second case, and the number of black balls will be x plus 6. The probability of drawing a black ball is now double. This time in the second case, the probability of getting black ball is double of what it was before. It was before means in the first case. You have to find out x. Let's write down the answer. Question number 4. Total number of balls is 12. Number of black balls is x. Therefore, probability of black ball, getting the probability of getting a black ball will be equal to number of black balls over total number of balls. This is first case. Then 6 black balls are added or put in the box. Now total number of balls, this is important, what kind of balls have been added. Total number of balls increases by 6 and the number of black balls also increases by 6. Therefore, probability of black ball in the second case will be equal to the number of black balls over total number of balls. So x plus 6 over 18, this is second one. Now according to question, this probability, the new probability, is double the old probability. If you want, you can write down that new probability equals to 2 times the old probability. From here you can make your equation. So this probability x plus 6 over 18 is equal to 2 multiplied by this probability x over 12. Solving this, simplify, this becomes x plus 6 over 18 equals to x over 6. So 6x plus 36 cross multiplying equals to 18x. So 36 comes out to be 12x, x comes out to be 3. So this is the number of black balls in the box. Now let us do fifth question. A jar contains 24 marbles. Some are green and others are blue. If a marble is drawn at random from the jar, the probability that it is green is 2 by 3. Find the number of blue balls in the jar. Total number of marbles is given. Some are green, some are blue. You can use one variable for green, but you don't have to use second variable. If you have green balls, if you have green marbles represented as x, then for blue, total minus x. This is what you can do. You don't have to use two variables unless you need to. So this, in this case, the total was given. I have taken one of them as x, the other one will be 24 minus x. The probability of green is given. So if you want to write down the probability of green from here, it will be x over 24 and it is equal to 2 by 3. So that makes an equation in x. You can solve, you will get the value of x. That means you will have the number of green balls, and once you have the number of green balls, you can find out the number of blue balls. Let's do this. Question number 5. Total number of balls, it's marbles. Total number of marbles is 24. Let number of green marbles as x, therefore number of blue marbles, I am not letting it, I am obtaining it using these two, total minus the green ones. According to question, probability of green marble is 2 by 3. So if I had to write down the probability for green marbles, I would take the number of green marbles over the total number of marbles, x by 24. This is equal to 2 by 3. Simplifying this, this comes out to be 16. So green marbles are 16, therefore blue marbles will be total minus 16, this is 8.